Wire bonders with an automatic pattern recognition system always contain a camera which is used to position the bond tool in the precise bonding spot. This camera can obviously not be in the same position as the tool itself. In fact, there is a considerable offset of 10 to 20 mm between the optical camera axis and the tool axis. This is particularly important for rotary bond heads, such as the wedge-wedge bond heads, and it becomes especially critical as the bond pads get smaller and the bond wire gets thinner. This camera offset changes slightly every time the bond tool is changed, so it has to be freshly determined in this case. Fortunately, this is not difficult. It can be done with a partly automated process by making a circular pattern of trial bonds on a standard bonding surface and measuring the positions of these bonds using the bonder camera itself. Depending on how accurately the camera offset needs to be determined, between 4 and 32 trial bonds can be made. In this example, we have chosen 16 bond wires. Their length and spacing can be chosen at will. In our case, around a circle of 1.1 mm diameter and with a loop length of 1 mm. The bonder then makes an automatic run with these bond wires. Once all the bonds are made, the operator locates their positions using the camera. First, a search window is defined of roughly the size of the bond. The operator can then place the search window on top of the bond with the mouse, or else moves the bond table with the bond itself under the search window. Either way, the deviations are registered by the bonder software. By the way, either the source or the destination bond can be located. This choice is up to the user. The bonder moves around the entire circle of bond wires until all positions, 16 in our case, are located. Once all the bonds are located, the software calculates not only the offset of the camera axis to the center of the bonded circle, but also a measure of its eccentricity. This reflects the fact that the bearing for the rotary axis may show a small deviation from a perfectly circular shape when turning. For extremely high accuracy requirements, more bonds can be made and measured to determine the precise actual offset at any given bond angle. This is why up to 32 test bonds can be included in the determination. After the offset is calibrated properly, the bond lands exactly where it should in the programmed spot.